Hello, everyone. I hope I'm audible. Dear authors and invited guests, welcome to the technical session 9C. Myself, Siddhi Auti, and I'll be your session moderator for today's session. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being organized via Zoom meeting today and tomorrow, that is 16th and 17th, which is yesterday and today. I hope you all will enjoy this knowledgeable and interactive session throughout the day. Now, in this session, we will be having total 10 presentations from 10 presenters, and each one will be given a time span of 10 minutes, 8 minutes for the presentation, and 2 minutes for question and answers. On 9 minutes, I will be raising a gentle reminder. So please consider the time constraint. Also, there is another request to all the participants that you all stay connected with us till the closing remarks. And if you face any issues or queries, write it to me in the chat box. And now, just before we start with the session, I would like to introduce you all to today's session chair, Dr. Vishal Patil. Dr. Vishal Patil is an associate professor in the Department of Artificial Intelligence and Machine Learning at Loknitya Gopinath Munde Institute of Engineering, Education and Research, Nashik, India. With 12 years of academic experience and research experience, he specializes in data science and AI. Dr. Patil dedicated to advancing innovative technologies, fostering student developments, and contributing to cutting edge research in the fields of AI and machine learning. Welcome, sir. Welcome to today's session.
Thank you.
Now, let's get started with the first presentation. So the very first presenter we have here today is Path Shinge from Vishwakarma Institute of Technology, and the paper title is A Hybrid Framework for Adaptive Prompt Generation Using Templates, LLMs, and Learned Rankers. Sir, please start with your presentation.
So, everyone, today I will be presenting our work titled Hybrid Framework for Adaptive Prompt Generation using Template, LLMs, and Learner Framework, which has been accepted. This work focuses on improving how prompts are generated for AI tools by making them adaptive, user-centric, and interpretive. So, moving on to the background and motivation, the engineering plays a crucial role in how effectively we interact with creative AI tools. However, purely template-based prompts lack flexibility, while purely LLM-based prompts can be inconsistent and hard to control. Because of this, there is a growing need for adaptive systems that can understand user intent and evolve with user preferences over time. The problem statement existing from generation system faces three major challenges. First, they do not systematically learn from user references. Second, they struggle to adapt over time as user needs or domain change. And third, most automated systems act as black boxes, offering very limited interpretability. These limitations motivated us to design a more transparent and adaptive solution. Our work makes four main contributions. We propose a hybrid framework that combines templates and LLM-based prompt generation. We introduce human-in-loop learning, where actually user choices are used as training. We develop an embedding-based learner anchor to predict user-preferred prompts, and finally, we focus on interpretability and reproducibility, making the framework easy to understand and replicate. Now, moving on to system architecture. This slide shows the overall workflow of our system. The process starts with user input. Multiple prompt candidates are generated using offline templates and the Gemini algorithm. The user choice is then logged as reference data. This data is used to train views. This data is used to train neural network which learns user references over time. Finally, the ranker adaptively selects the most preferred from enabling continuous improvement. Now, our key framework features are it uses hybrid prompt generation, combining structured templates with LLM creativity. It incorporates human in the loop learning, ensuring continuous adaptation, and embedding base neural learner anchor predicts user preferences effectively. And through ensemble prompt synthesis, we achieve prompts that are both fluent and well structured. Ranker is built using system transformer embedding with all LLM L6 version 2 as the default model due to its speed and accuracy balance. A lightweight neural network predicts user preferences based on embeddings. The system learns directly from the explicit user choices rather than static rules. Importantly, the framework is embedding agnostic, meaning the authored sentence in common model can be easily swapped without changing the architecture. To evaluate we collected real-world user interaction data. We compared our method against multiple baselines, including random selection, popularity-based methods, and PFIDF with logistic regression. We use five-fold cross-validation for robust evaluation measuring accuracy, recall, precision, and F1 score. Now, results and observations. The results clearly demonstrate the effectiveness of our approach. Our embedding-based ranker outperformed baseline methods across multiple metrics. We also observed strong sample efficiency with high performance even under limited data conditions. Additionally, human evaluation showed a clear preference for prompt generated by our accessible approach. In future, this framework can be extended in several directions. We plan to integrate multiple LLMs such as ChatGPT and Claude, enhance ensemble synthesis using advanced optimization techniques, deploy the system at production scale with drift detection and auto retraining, and finally expand this framework beyond design tools into other domains. To conclude, our work bridges structure and creativity by combining templates with elements. By learning from human preferences, the system becomes truly adaptive and user-centric. The framework is extensible, transparent, and reproducible, making it suitable for both research, real-world development. Thank you.
Thank you, sir, for your presentation. Now we will, if there aren't any questions, we will go on to the next presenter.
Is there any hallucination problem in your LLM? Can
No,
you
there
explain
won't be
transformer?
Yeah, there won't be a hallucination problem, but in the offline model, we have a systematic, determined prompt generation. So whenever user generates prompt using the offline, only the words are being replaced with the current topics and other things. And by using the Gemini model, the hallucination doesn't occur as every time a new API request has been forwarded to the Gemini.
So are you going to integrate agents here?
Yes, I have already used the Gemini. I'm thinking for using others too, like the ChatGPT Claude. But currently, we don't need them as Gemini is working pretty good.
Okay.
Okay, so we'll go on to the second presenter. So the next presentation is by Hima Chandana from Annamalai University, and the paper title is An Overview of Video Summarization Using Deep Learning Techniques. Ma'am, please start with your presentation.
Yes, ma'am. Ma'am, is my screen visible?
No, ma'am, you haven't shared your screen yet. We can't see it. Okay, now it's visible.
Okay.
Yes.
Uh, good afternoon, respected panel members. So I'm a research scholar working under the guidance of Dr. Raghupati and Dr. Vivekananda Reddy from Annamala University. So
Ma'am,
this is my.
sorry for the interruption, but we can't see your PPT. So, like, you have to go on the PPT slides.
Is this okay, ma'am?
No, ma'am, we can't see it. We are seeing the security and privacy tab only.
Ma'am, now, ma'am.
Yes, ma'am, now it's visible. Please continue.
Okay, ma'am. Good afternoon, respected panel members, and my name is Himachandana. I'm a research scholar working under the guidance of Dr. Raghupati and Dr. Vivekanand Reddy from Annamala University. So this is my second survey paper, literature survey paper. First, I have done the survey on the machine learning techniques for my video summarization, and now I'm working on deep learning techniques. So initially. The problem statement is a video summarization for my work, and basically, since technology has developed so quickly in recent years, we have it has included into a wide variety of gadgets. Individuals frequently record their everyday routines and memorable events, producing vast amount of video information. The number of videos on internet has increased dramatically as a result of mobile devices making it simple to produce and stake videos on social media. And it can take a lot of time to find and classify particular video content. Conventional techniques that describe a video as sequence of consecutive frames are effective for viewing movies or any other videos, but they are not much suitable for modern multimedia services such as video browsing, context-based search, retrieval, and navigation. So, coming to the main problem statement, so this is the drawback regarding the videos which we see on internet, and what exactly the video summarization is. So in the name itself, it says like getting the summary of a video is nothing but a video summarization. So which is nothing but we'll apply some techniques on that, and we'll get the summary of a video, which is nothing but if we just give a movie and we have to get the trailer from that, that is nothing but video summarization. But I mean, official definition is like it is a process of shortening a set of data computationally to create a subset or a summary that represents the most important or relevant information with the original content. So that is the main motive of video summarization. And this video summarization is like two types. One is static keyframe video summarization, and the other is dynamic or skimming video summarization. So, static video summarization is nothing but it creates a collection of keyframes representing important scenes, focusing on image information without any motion. And whereas here I can say like this is exclusively for images. So whichever the video we have taken in this static video summarization, the video is going to get converted into number of frames or images. So obviously we are going to apply the image processing for this static summarization. And next type is the dynamic video summarization. So in this, it generates the short video clips that maintain temporal flow motion audio and offering a richer fluid experience. So which is nothing but here, instead of converting the video into number of frames, here it directly converts into number of video shots or video clips. That is the main difference between the static and dynamic video summarization. So here the techniques which we are going to use is also video processing. So in the static, we use image processing, and in dynamic, we use video processing for the summary process. And next, this is the basic flow of process of video summarization for any type, like either it is a static or dynamic. This is the flow of process. Initially, we'll take the video, whichever the video we want to convert, we will take that from the database, and then that is, this is the input out video, and then it is divided into number of frames according to the static video summarization, and here it is also divided into number of video clips according to dynamic video summarization. And after this, feature clip selection is done. Feature clip selection is nothing but important features should be extracted from that particular video. I can give an example, like, for example, if we have a 2-minute video of cricket video, where the batsman has scored two sixers, for example, at 45th second, first six has been scored, and 1.36 second, the second six has been scored. So these two are the highlighting features of the entire video. So this type of features are selected here after dividing it into frames. These type of important features are selected from the video, and then it is analyzed with the techniques. Techniques might be like many things. In this present survey, I have came across 10 different techniques which are quite optimal for getting the summarization. So we can apply any of those techniques for the feature clip selection or important clip selection. And then after applying that techniques for the prediction processes, then we will apply the clustering technique for that, for grouping up of the important features. And then finally, we'll get the summarized video as the output. And next we have these are the three types of learnings which we have pretty much know: unsupervised, supervised, and reinforcement. Definitely we have to use all these techniques in this process. As I said, after applying there are many different techniques, we have to apply the clustering process. For that, we use the unsupervised. Next, supervised, which is used for human labeled data to train or mimic the human understanding, and reinforcement learnings. Everything is used for the videos to attain the video summarization process. And then we have these are the 10 main methodologies which I have came across in my literature survey. So first one is the GVSUM, which is the generic video summarization, which is quite optimal in attaining the summary of any video. Even if we can take a full length of a 30-minute video or 40 minutes video, it is capable of producing the trailer or a summary for that. So what basically happens in this is, so it is done by the selection of keyframes at the instance of a major scene changes in the video, and each frame of the video is trusted a cluster number depending on its visual features. So we'll extract the by changing the cluster number, and then we will apply the convolutional neural
Hello.
network.
Ma'am, sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Yeah, yes, ma'am. So these are the different techniques I have came across, and I want to, in my future work, I want to work on any of these technique. And coming to the data sets, they have used many different data sets, and few techniques have used their own data sets, and TV summy data sets they have used, and which has got like around 50 videos and like duration of 1 to 4 minutes. And applications, we can do it for like egocentric, medical, sports, everything we can use. And in the future scope, I want to work on any of the spatio-temporal technique or graph based, all these things. I want to extend my future work on this. And finally, so concluding this, like, there are numerous ways to classify video summarization techniques, but depending on type of output summary, the type of input video, several strategies are employed. And so, yes, ma'am, that is about the video summarization. Thank you, ma'am. Thank you, sir.
Thank you, ma'am, for your presentation.
Which deep learning model you are using here?
Sir, actually, I have taken 10 models, sir, but in future I would like to work on spatio-temporal or GV sum, sir.
Okay. And why don't you go with machine learning?
Sir, actually, even in machine learning, that was my first survey paper, sir. But in machine learning, I have came across, but just for deep learning is a bit next version for that. So I'm thinking on doing this, sir.
Which feature selection technique you are using?
So feature selection for the image processing, we'll use the convolution neural network, sir.
Okay.
Yes.
Thank you, ma'am. Thank you, sir. Now I'll get on to the next presenter. The next presenter is Sachin Bhosle from Sandeep University, and the paper title is Deep Learning Approaches for Brain Tumor Detection and Categorization. Comprehensive Survey. Sir, if you're there in the meeting or if any of the co-authors are present, please give us a response.
Good afternoon, ma'am. I'm here.
Good
Hello.
afternoon. Sir, you can start with your presentation now.
Is it visible to you, ma'am? My screen is visible to you?
Yes, yes, it is visible.
Good afternoon, everyone, all the panel members. So I'm really thankful for giving me opportunity to present my title. That is Deep Learning Approach for Brain Tumor Detections and Categorization generally. So nowadays we are working on n number of things to categorize that brain tumor detection by using MRI. By combining, we can say convolution neural, that is CNN. So CNN is specially used whenever we want to categorize any MRI images. CNN, that is basic, that is convolution neural network, is actually used to accept the image, generally process the image, and then it actually used to generally convert into meaningful data. So I want to have a combination. I want to design one future approach, multi-model approach, that is combining CNN with transformer model, which actually used to effectively generalize the global and local features of that particular images coming from the MRI scan generally. So if you transfer the CNN generally used to focus on the local features that coming from the MRI images, and when you want to have a global feature extraction. For that purpose, we can able to use vision transformer here. So generally, what's idea is whenever we are getting any MRI images of brain tumor, we want to detect whether it is tumorous or non-tumorous. A n number of systems are available, but in natural clinical trials, we face n number of issues generally. To deal with those issues, we want to design such systems so that any real-time scenario we can able to implement our system. So for that purpose, we are using a concept called as lightweight architecture, that is called as mobile net. So whenever we want to deal with any clinical trials that is for real-time applications, we can go for this mobile net applications. But we can observe the n number of shortfalls of MRI images generally. For that purpose, we are going to use generative adversarial network, that is GAN. So for that purpose, we want to mimic that images, multiple copies, and we can able to distinguish which are the tumorous images and which are the different non-tumorous images. So this is a good approach that is used to design to find out whether the images are brain tumorous or non-tumorous generally from MRI data. So this model integrates, we can say, CNN, that is convolution neural networks, which actually used to extract local features. But whenever you want to show some detailed information, generally, whenever we have images that contain some MRI images, that contain some healthy tissue also that contained by particular images, generally. So for that purpose, we're going to use vision transformers. We want to combine both these features. That is a hybrid approach. And by using GAN, that is generative adversarial network, so we can able to use image data and then lightweight uh, approach, that is called as mobile net for real-time processing. So for that, we are using BRATS datasets near about for handling those images for our trial purpose generally. So brain tumor detections using the traditional methods obviously is time consuming and is required radiologists having highest knowledge generally, but we have observed n number of hospitals are available nowadays. It doesn't have that specialized brain tumor detectors, or we can say radiologists. At that time, suppose we want to detect it, whether the images are tumorous or non-tumorous, we can go for this approach. So that is brain tumor detection generally. For that purpose, we are using a concept of deep learning, that is CNN, that is convolutional neural networks, that we use to extract the local features, and we also use a transformer. Here we are going to use a vision transformer to detect local and global feature extractions. So, this hybrid approach that combines CNN and vision transformers to boost the performance enhancement generally. So here, a number of literature surveys I just want to keep it generally. So I'm observing a number of literature surveys are there, but they are not with that particular point. Suppose whenever a number of papers are there that work on CNN, that is convolutional neural network generally, RNN that basically works on RNN, but whenever we want to have a detailed information, at that time we fails to deal with that point. For that purpose, we want to have a hybrid approach that comes under the CNN and vision transformer, which actually used to bridge the gap of that particular research gap. So I want to work on this topic generally. So I just try to directly work with my proposed architectures. So my proposed architecture, initially I want to have some MRI input images, and I want to pre-process that images. Pre-processing generally includes the MRI images, brain images, and we actually use the pre-process. We can say that is skull stripping, that is removing the unwanted, that is non-brain regions from the images. Then we want to perform some data augmentation, multimodal fusions, that is pre-processing generally. After pre-processing, the clear images provided to the GAN, that is generative adversarial network. So for the synthetic data generation, there we actually use to apply this GAN, and then we are going for the CNN feature extraction. So this CNN feature extraction we will use to extract the image, extract the features and local features, and then send to the transformer. Here we can go for the vision transformer. So there are the global dependencies are available for the vision transformer. It's widely used in today's scenario generally. So we can deal with have a cell potential generally, how detect accurate that blend to that region where actually we can able to have a cells or tissues that contain some tumor generally. So after this, we have to go for the mobile net application. So we have a number of systems we can able to directly deal with live scenario, directly scenario events where some lightweight resources are required. So within the some lightweight resources, we can able to apply this mobile net so that anywhere with a limited resources computer systems, or we can say where we can able to work on this one directly. So by using mobile net with lightweight architectures, we can able to extract the able to execute our applications. In multimodal features, we can say apply this multimodal features which actually use to extract different MRI modeling T1, T2 flare, and we can able to send the final output, that is for the classification layer. In the classification layer, we can able to deal whether the images that we are capturing contain tumor or non-tumor. We can able to predict this scenario
Hello.
in this architecture. Yes, ma'am.
So
Yes, ma'am.
sorry for the interruption, but we are past the presentation
Yeah, yeah,
time
yeah,
now.
yeah, ma'am. Yeah, I just concluded now. These are the different points here. So there are data augmentation, that is pre-processing, that is I'm just explaining here, then GAN-based augmentation, which accepts the images, then feature extraction generally, which actually use the CNN for the local extraction and mobile net for the and that actually works on the clinical trial generally. Next one, that is classification layer, that is use whether it contains tumor or not. We are using fully connected layers like softmax activation layers, and we are also working for the dropout, that is used to prevent overfitting. Overfitting, we can say, suppose we are used to train the model with similar data generally, with some noise generally. Next time, suppose we want to have the same data again with that trained model, it actually provides a different output. To overcome this issue, we are using overfitting generally. Just we want to remove that overfitting, and you can able to use some broad data set for handling this one. So this hybrid deep learning approach, we can say, is used to detect brain tumors by combining convolutional neural network, that is CNN, and vision transformer effectively, so that we can able to capitalize local feature as well as global dependency self-attention mechanisms. By using the GAN, we can able to mimic data that is used to provide the problems of imbalance of data set generally. And for the mobile net, we can able to solve the issues of lightweight architectures and for real-time clinical trials generally. So we can say our system will work properly where we required it. There is no possibility of radiologists, and we want to have a predictions with a clinical trial generally. So that's all about from my side. Please have a query. Please, hello.
Hello.
Hello. It's over from my side.
Okay. Thank you, sir. Thank you for your presentation. Now we will go on to the next presenter.
Thank you.
So the next presenter is Babani Sanskar Behera from KIIT University. And the paper title is From Innovation to Impact, ICT Practices and Technologies for the Future. Sir, please start with your presentation.
Okay. Good afternoon, everyone.
Good afternoon.
Is my slide visible?
Sir, you can start
Hello?
screen sharing now. Hello. Sir, is there any issue?
Uh, am I visible? Sorry,
No, sir, we can't see your screen yet.
I could not maximize.
Hello. So we can't see your screen. Can you share your screen? Sir, if you need some time to figure it out, what we can do is we can have your presentation after another presentation. So you'll just get some time to figure it out.
So, ma'am, next I will present next
Yes,
after this.
sure, fine.
Okay.
So let's take the next presenter meanwhile. So the next presentation is by Upasana Singh from Ajinkya D.Y. Patil School of Engineering, and the paper title is Integrated Research on Cognitive Load, Emotion and Keystroke Mouse Dynamics. Ma'am, if you're there in the meeting, please give us a response. Okay, so we'll go to the next presenter because I think she's not there in the meeting. The next presenter is Leo Raju from Sri Siva Subramania Nadar College of Engineering, and the paper title is IoT-based Smart Rural Water Distribution System. Sir, please start with your presentation. Hello.
Hello, am I audible?
Yes, yes, sir, you are audible. You can start with your presentation.
My screen is okay.
Yes, sir, your screen is
I'm
visible. Please
okay.
go ahead.
It's okay. I'm Yogesh. I will be presenting this paper, and our paper title is IoT-based Smart Rural Water Distribution System. So I'm Yogesh GS, and my co-author is Rio Raju, and we are from SSN College of Engineering, Chennai. So these are the contents present in our paper. Let's start from the introductions. So the provision of clean and consistent water is a persistent problem in rural areas, especially in developing nations. So for example, when we take our developing nations like India, we have a difficulty for the provision of clean and consistent water. So what we plan is to suggest a overacting IoT system based platform based on LoRaWAN technology to provide a fair and sustainable management for rural water resources. So by implementing this IoT system, we can effectively distribute the water distributed networks, and it will be access upgrade for the old infrastructure and poor. And currently we have a poor real-time monitoring systems. So this contribute to the water shortages and unequal access in the rural areas. So by implementing the system, we can uh, we can do certain measures to conserve the water. So the proposed system includes a low power water monitoring sensors and solar power gateways and central platforms for real-time data analytics, which will be discussed in the later slides. So it is designed. So our main goal is to what we plan to design a system to monitor the water usage, detect leaks, and manage the fair distribution among the rural areas, so that water resource is delivered to all the regions equally. Um, so by using the LoRaWAN's advantage of long range and low power functionalities, this guarantees the affordable scalability and connectivity robustness appropriate for rural developments. So this system aims for higher efficiency in water use and loss savings and water conservation at a community level. So this works also cover the implementation of the smart water distribution in rural areas, targeting efficient and economic water distribution up to 3 kilometers distance. So these are literature review. We just reviewed certain papers for which have already been published. These are taken from the IEEE websites. So Adelanto F, Achilles IF. So these are the authors and their and what they have presented in their paper. I have been given in the slides for your reference. So these are the papers we referred to develop this system, and these are the other authors. So let's move on to the problem statement. The central problem is addressed by this work is the provision of clean water and consistent water in rural areas, especially in developing nations, where this remains a persistent issue. So what contributes to these problems means the poor real-time monitoring of water resources, ineffective distributed network, and old infrastructure are the main reasons for these conflicts. So in order to tackle these conflicts, we designed a system with LoRaWAN, which is affordable, smart, and scalable IoT system. So these are the objectives of our paper. The main objective of our system is to support a long-range communication. The LoRaWAN supports long-range communication, which will be discussed in later slides, and real-time monitoring and predictive analysis using the AI-driven analytics and equitable distribution to promote equitable access through the distribution algorithms. So this collectively aim to achieve higher efficiency in water use and loss savings and overall water conservation at community level. So this is our system proposed methodology. Our system consists of 5 layers, which is a sensor layer, network layer, gateway layer, cloud backend, and user layer. So this system architecture, as I already told, these are the 5 layers. The system architecture is divided into 5 distinct layers. Let's start from the sensor layer. The sensor layer is responsible for tracking the water parameters. It monitors the water quality, such as turbidity, pH, and pressure through the LoRa compatible sensors. And these will be displayed in the dashboards. And the network layer, which handles the data transmission between the nodes. The LoRa nodes send and receive the collected data through the gateway via LoRa. So each pipes are fitted with the LoRa nodes, which will be connected with the server node, which is also known as a gateway, so that we can all the water parameters which are measured using the LoRa from the pipe from the water distribution side, we can see it in a collective environment, so in a dashboard. So we also use the gateway layer, which is acts as a relay to the cloud. Solar power gateways forward this data received from the node to the cloud with the help of the cellular backhaul, for example, Wi-Fi or 4G or 5G or any other wireless networks if it's available there. So we also use the cloud backend. This central platform handles data processing and analytics. It involves a real-time data ingestion using a AWS IoT core and analytics using InfluxDB. This is nothing but, for example, if it collects all the data with the timestamps for the reference, and Grafana, which is used for visualization using a graph or any other gods like um, settings. So we also use the ARIMA models, which is auto-regressive in integrating algorithms. So And moving on to the user layer, this layer provides the interface for the users. It includes the dashboard for local authorities and community leaders, and mobile notification for the anomalies and shortages. So let's move on to the implementation. I already introduced you to the all the sensors and the components we used in this the system. So let's talk about the LoRaWAN furthermore. We deployed a 10 LoRa-enabled sensor node where installed the key location, including the borewell, overhead tanks, consumer-level taps, and each sensors are fitted with the pressure sensor, pH, and turbidity sensor. The hardware we used the node with the Arduino Uno. We can also use ESP32 if you want. So these are this LoRa WAN is this LoRa controller is LoRa SX1276 modules, and these nodes are powered using the 20-watt solar panel combined with the lithium-ion battery packs for the energy storage. So that we will be also focusing on the sustainable practices from our side. So let's move on to the gateway, and we use a node to gateway communication, which is managed by a LoRa working at a 868 megahertz using adaptive data rate optimized up to 5 kilometers. And these are tested in our institution, around the institution with the various setups and various distances to calculate the efficiency and the data transmission range. And this also includes gateways were implemented using the Arduino Mega boards with the SIM 7600 GSM module for the cellular support, if to transmit the data to the cloud server. So we also use the cloud platforms like Blink or UbiDocs for visualization, which can be so that the data can be visualized using anywhere. So these are the other sensors, basic sensors we used while in our institution for like a basic circuit. We just designed the basic circuit before going for a bigger implementation. We use the water flow sensor, which is used to detect the flow between the two pipes. So if there is a difference between the flow of water between the pipes, there will be a change in flow. From this, we can determine there is a leak between these two pipes, so that we can send the professional to repair those pipes. And we also got the turbidity sensor to measure turbidity, and water pressure sensor if there is any problem with the distribution. This also check for the water pressure at that particular time and sends the data to the InfluxDB and Grafana for visualization. And let's move on to the cloud backend analytics. So data handling, data was consumed into AWS IoT Core and persisted in InfluxDB for real-time dashboard rendered by Grafana. So why we did this? So users will be, if users are aware of their how much water they are consuming, they will be if they are aware, there is a slightly a chance to lower their usage, so that it is important to give the dashboard to every individual. And for professionals, the alerts will be given via SMS with the Twilio API. If there is any pressure drops or any leaks, these were designed. And AI forecasting, we used our Python library, Arima library, to predict hourly and daily water requirement. So we can schedule the water distribution. So this system was monitored for 3 months, recording the sensor every 15 minutes for daily for the real time and historical analysis. So these are the results we got from our system. So I have mentioned the features and result and what are the impact we got. So we noticed that 98.7% of the average network availability, and this shows the LoRaWAN's connectivity robustness even in adverse weather. So 96.4% of packet delivery rate, such as our data is successfully delivered, which is achieved using the LoRaWAN adaptive rate. And leak detection, 22% of leak were detected and successfully repaired. And this is achieved through the comprehensive algorithms we use in this device. And forecast accuracy, or our system is determined to achieve 91% of accuracy and assisted in the predictive allocation of water during the higher demand period, supporting the equitable distribution objective. And we noticed that 30% increase in satisfaction resulted from the transparent and traceable water distribution, demonstrating the social sustainability. So Moving on to the discussion, we discuss about the system benefits. As I already told, this is a we use dashboard to monitor the leaks and identify peak usage hours. So if we require, we can also some introduce some measures to monitor the peak hours, so that we can effectively distribute the water among the all the individuals. So alerts will be given through the SMS via Twilio API. And LoRaWAN role in sustainability, this LoRaWAN is successfully demonstrated its capability of long distance communication. We achieved the communication up to 5 kilometers with ADR, which is adaptive, right? So this is also a low powered system. We use the 20-watt solar panel lithium ion packs to power up these devices. So why we choose this model? Because when compared to the conventional models, we use LoRaWAN because this communication is longer range and it uses lower power and compared to the other conventional models, which they have limited range and they use high power. Example, Bluetooth, Wi-Fi, Zigbee. And even when we use the cellular networks, in even some rural areas, there will be a poor network reception. So we believe LoRaWAN is a good approach. And when coming to scalability, LoRaWAN, it's easy to cover long areas when compared to conventional models, and this requires the minimal infrastructural needs. And even in case of when compared to the conventional models, they require the wired connections if there is no wireless options. So it's require extensive wiring and prone to damage, and it's not economical for use.
Hello,
So
so
these
okay, fine. You're already on the conclusion side. I just wanted to give reminder. Please continue.
Okay, these are the future works. So our future works will focus on scaling and enhancing the platforms, extending the system to larger scale deployments, implementing improved AI features. We plan to introduce more AI in the system for better predictive, and we just use the basic now. So we plan to implement more AI features in this system, and we plan to integrate with the government digital platforms so that user will be aware of their water usage. So exploring the participatory aspects like mobile feedback portal and multilingual alerts to enhance the user participation and transparency. So on moving to the conclusion, I already give the brief introduction to LoRaWAN and IoT systems and how it can be used for the water distribution to rural communities. And the system offers an assured and green solution for water management combining low power sensors and renewable power and smart analytics. So the pilot test confirmed the feasibility of the large scale deployment of the system. The outcome proves a higher efficiency in water usage and loss savings and water conservation at the community level. So on moving to the reference, these are the reference we used to refer for this system, and these are the other authors. So thank you.
Hello, sir. Now you can present. Behera, sir, you can start with your
Thank you,
presentation.
ma'am. Thank you so much.
Yes, please share your screen.
So, is there any question for a previous presentation? Hello.
Yes, sure.
Hello,
Is
sir.
it
Is there
visible?
any issue
Yes,
with
for
the
the
PPT
presentation
presentation?
because I'm author of the paper. I'm just waiting for any questions related to the presentation done by students now. No questions.
So I think there are no questions about this.
Okay.
But
Thank you very much. Thank you.
thank you, sir. Thank you for your presentation.
Yeah.
Okay. Now, sir, if
Ma'am,
you
give me
are
some time,
not,
please. Next.
yes,
There is
sure,
some
sir.
technical issue, ma'am.
Okay, we can have another presentation meanwhile. And sir,
Okay,
if
ma'am. Okay,
there's
ma'am.
issue
Yeah,
from your
let me rejoin.
device,
Let me rejoin. I will do it. Let me rejoin.
yes, sure, sir. You can share the PPT to me or otherwise, and I can share on
Okay,
your
ma'am.
behalf if you want.
Okay, ma'am. Okay, ma'am. Thank you.
Yes. So the next presenter is Pranjal Kar from Center for Development of Advanced Computing, CDAC, India. And the paper title is Leveraging Autoencoders and Big GNs for Resilient Intrusion Detection in Evolving Cyber Landscapes. Sir, you're there in the meeting. Please start with your presentation.
Yeah. I hope my screen is visible.
Yes, sir.
Yeah. So good afternoon, everybody. I am Pranjal, and this work was done jointly with Dr. Muralidharan at CDAC Bangalore. Today, I will be presenting our work on leveraging autoencoders and bygames for resilient intrusion detection in evolving cyber landscapes. So as we know, the cyber landscape is evolving extremely fast, and with the advent of growth of public key infrastructure, and it has led to the exponential growth in connected devices and network traffic, which has led to complex dynamic cyber threats. And the traditional intrusion detection systems that rely heavily on static rules and signatures can't. These are ineffective against zero-day and evolving attacks, which motivates the need for adaptive and intelligent detection mechanisms. Now, deep learning offers a different new paradigm for intrusion detection. Unlike rule-based systems, it helps in hierarchical learning patterns directly from no raw network traffic. This enables the detection of complex and previously unseen attack behaviors. So now, looking at in our paper, we have looked at various research gaps and contributions from various authors. So we have seen papers in various approaches, from traditional IDS to vanilla autoencoders, GANs, and so on. So in this paper also, we build upon these insights and propose two complementary deep learning paradigms that will enhance detection accuracy, reduce false positives, and strengthen adaptability. So now, coming to the proposed methodology, our study evaluates two novel deep learning models for performance and resilience. The first model is an autoencoder based classifier that we are proposing. So the main features of this model is that we are using stacked LSTM layers along with a self-attention mechanism, which will capture and reconstruct the intricate sequential and temporal dependencies in the network traffic behavior. And it combines unsupervised learning, feature learning, along with a supervised classifier. And we have used a custom hybrid loss function where we have utilized Hubbard loss and categorical cross entropy for optimization. And the second model that we have proposed is a adversarial bidirectional generative adversarial network. So here we have extended the traditional GAN by incorporating an encoder that will help in learning bidirectional data latent space mappings, which will make it crucial for learning reconstruction and representation learning. So its function is it is trained as a minimax game, and it captures normal traffic patterns to perform unsupervised anomaly detection. Now, coming to the deep down on the first architecture. So here we have used two LSTM deep layers of 64 units and 32 unit layers. It will capture the sequential information in traffic data. Along with that, we've used self-attention layer that will help in extracting the temporal dependencies in the sequence. And for stabilization, we've used batch normalization and dropout. And this is for the encoder part. For the decoder, it basically just mirrors the encoder architecture as part of the encoder architecture, and it helps in ensuring the accurate data reconstruction. The data reconstruction is maintained using our custom Hubbard loss that we have defined. So once the reconstruction loss is suitable for optimum loss, then we freeze the encoder layers and then we attach a classifier layer. So the classifier is a feed-forward network with dense layers of 32 units and 16 units. So it processes the latent representation and it finally gives an output to classify as normal traffic or intrusive traffic. And the key novelty in these are using the attention mechanism in the autoencoder model and the hybrid loss function, where we have utilized Hubbard loss along with categorical cross entropy loss, and we have also used L2 regularization. This is that was for the first architecture. Now coming to the second architecture, the Huygens architecture. It has three components: generator, encoder, and discriminator. The generator produces synthetic network data from the noise, and the encoder takes the real data and converts into the latent space. Now, both the encoder and the generator provides this data to the discriminator. The discriminator is the referee here. It learns to distinguish the real patterns from the generated patterns. So the generator and the encoder are trained to fool the discriminator, and the discriminator is trained to get better at spotting fake network traffic data. So the outcome is it learns a rich underlying distribution of normal traffic. Any data that doesn't fit in the learned distribution is flagged as anomaly. Now, for evaluating our models, we have used two widely recognized cybersecurity benchmark datasets. One is CICTCS 2017 and NSL-KDD. So these include various type of network attack data. And the pre-processing pipeline for our processing the data is we used various stages like extraction from PCAPs to CSV using tools like TSHAC and CSV formatter. Then we did some cleaning and scaling. Then we did some feature engineering like creating new metrics like packet inter-arrival time and so on. Then we saw that the data was heavily imbalanced. So we utilized SMOT, that is synthetic minority oversampling, for addressing the class imbalance. And then finally we split the data into 70-30 ratio for training. So after training the models, these are the final results from the from our models. So for the NSL-KDD, our autoencoder proposed achieved a accuracy of 92%, which is a utilized semi-supervised architecture, and the Beigen achieved accuracy of 90. And for the CICTS 2017, sorry, maybe I got disconnected. Hello, am I audible?
Hello. Yes, sir, you are audible.
Okay. So as I explained about the results, now another important feature in the real world intrusion detection system is resilience. So our models we tested against various data degradation adversarial conditions like missing data, feature corruption, noise injection. So our models demonstrated strong generalization, and it is suitable for near real-time processing in large network environments. So here is the detection capabilities by attack category. You can see the chart. So our model performed well in DOS and probe attacks. Now another, as I explained earlier, our model study basically gives us two key findings. That is the trade-off between the unsupervised and the supervised learning. So the Beigen model, which is a completely unsupervised model, achieved 90% accuracy without any level data. So this demonstrates its strength in dynamic environments where new attack signatures are unknown, levels are scarce. And the key second finding is the balance of semi-supervised learning. So the autoencoder based classifier, which uses a semi-supervised architecture, it provides a balanced trade-off. It outperforms semi-supervised methods, earlier methods, and it requires less leveling than fully supervised model like XGBoost. So as we have seen earlier in the results, that while we may have achieved less accuracy than the fully supervised models like XGBoost, but our semi-supervised and unsupervised architectures achieve more resilience for significantly less reliance on level data, enhancing adaptability to evolving threats.
Hello.
Yeah.
Hello. Sir, sorry for the interruption, but we are past the presentation time. Please go to the conclusion part.
Yeah. So to conclude, basically we have derived two architectures. One is the attention-driven autoencoder LSTM, and Beigen for intrusion detection, which is has a better generalization and operational viability. In the future, we aim to explore hybrid designs that combine the flexibility of unsupervised model and precision of supervised learning. These are the references that we have used. Thank you for your attention. I'll be happy for any questions.
Thank you, sir, for your presentation. And if there aren't any questions, we can move forward.
Okay, thank you,
So
madam.
now the next presentation, sir, I'll be sharing the screen. You just tell me when you want the slides changed, okay?
Okay, ma'am.
Okay, just let me know when my screen is visible.
Now it is visible.
Okay.
Uh, Sorry for inconvenience.
No,
And
it's all right, sir. Just tell me when you want to change it, okay?
okay, ma'am. Please change the first slide. And good afternoon, everyone. Uh, my name is Bhavani Shankar Beran, and I am going to present on the topic from innovation to impact, ICT practices and technologies for the future. Now we know that nowadays we are living in a world where everything seems to be very easy and accessible. The 21st century has been set by the rapid growth of information and communication technology, which has become a defining feature of modern societies. It significantly influences governance, education, healthcare, business practices, and everyday social interaction. In recent years, the focus has shifted from technological innovation alone to the real and measurable social impact that ICT generates across different sectors and communities. Please, next slide. Hello.
Hello?
Ma'am, change the slide, please.
Yes, yes. Okay. Sir, I've changed it. Can you see it?
Ma'am, I can say it. Please change the next slide.
Okay. This one, catalyst for development.
Right. ICT as a catalyst for development, and ICT plays a very significant role in promoting economic development and social empowerment by improving access to information, services, and opportunities. It strengthens productivity, supports innovation, and enables individuals and communities to participate more actively in economic and social processes. Rather than replacing human abilities, ICT amplifies existing skills and capacities by enhancing efficiency, connectivity, and decision making. However, unequal access to digital infrastructure, skills, and resources continues to create a digital divide, leading to social exclusion and limiting the inclusive benefits of ICT. Next slide, ma'am. Risk gap and objectives. Most existing studies on ICT primarily emphasize short-term adoption and immediate outcomes, often overlooking long-term social and developmental impact. In developing nations, the effective use of ICT is constrained by structural limitations such as inadequate infrastructure, limited digital literacy, and ethical concerns related to access, privacy, and governance. In response to these gaps, the present study examines best practices, emerging technologies, key barriers, and potential solutions to promote inclusive, sustainable, and ethically guided ICT implementation. Next, ma'am. Thank you. The study adopts a qualitative research approach based on the analysis of secondary data sources. Data has been drawn from policy papers, peer-reviewed journals, and reports published by global and international organizations within 2010 and 2025. To ensure a comparative and contextual understanding, selected case studies from India, Estonia, Kenya, Rwanda, and the European Union are examined to highlight diverse ICT practices, challenges, and outcomes. Next one, best practices in ICT. E-governance systems enhance transparency, accountability, and administrative efficiency by streamlining public services and reducing bureaucratic delays. Digital educational platforms expand access to learning by overcoming geographical and social barriers, enabling flexible and inclusive educational opportunities. Similarly, similarly, telemedicine initiatives strengthen healthcare delivery by extending medical services to rural and remote areas, improving access to timely consulting and treatment. Next, ma'am, emerging technologies. Artificial intelligence enables advanced data analytics and automation, supporting improved decision making and efficiency across sectors. The Internet of Things facilitates the smart cities and the modern agriculture by enabling the real-time monitoring, resource optimization, and intelligent infrastructure management. In addition, emerging technologies such as blockchain, 5G, and quantum computing are shaping the future digital landscape by enhancing security, connectivity, and the computational capabilities. Next, ma'am, challenges and risks. The digital divide continues to limit the equitable distribution of ICT benefits, particularly among marginalized and underserved populations. Growing dependence on the digital systems has also increased cybersecurity threats and the data privacy risks, raising serious ethical and governance concerns. Additionally, automation and the digital transformation may lead to employment displacement, highlighting the need for rescaling and inclusive policy intervention. Next, now, major findings. And from this, we find that ICT generates meaningful social impact when it supported by ethical governance frameworks and inclusive policies that ensure equitable access and participation. Evidence from best practices demonstrates strong positive outcomes across key sectors such as education, healthcare, governance, and financial services. While emerging technologies significantly enhance efficiency and innovation, they also intensify risks related to social exclusion, surveillance, and algorithmic bias. Persistent challenges such as the digital divide, cybersecurity threats, and ethical concerns remain critical at the global level. Therefore, sustainable ICT-driven impact depends on public trust, transparency, and long-term policy alignment that prioritizes social well-being alongside technological progress. Next, ma'am. ICT and Sustainable Development Goals. ICT contributes significantly to the achievement of key development goals related to health, education, gender equity, and innovation. Digital tools enhance social inclusion and improve the efficiency and the reach of service delivery across sectors. However, sus- sustained policies support and inclusive regulatory frameworks are essential to ensure equitable growth and the fair distribution of ICT benefits. Next, conclusion. ICT must be guided by strong ethical principles to promote inclusive and equitable growth access across society. Effective governance, digital literacy, and sustainability are crucial in ensuring that technological advancement benefits all sections of society. Ultimately, the goal is to build a human-centered digital future that balances innovation with social responsibility and a long-term well-being. Thank you.
Thank you, sir, for your presentation. Now, if there are not any questions, then we can move forward. So the next presenter is Neeta Dukare from Datta Mega Higher Education and Research. And the paper title is Machine Learning for Early Prediction of Chronic Kidney Disease, Critical Challenges, Ethical Considerations, and Future Research Pathways. Ma'am, please start with your presentation.
Yes, ma'am. Good afternoon, everyone. I am Neeta Dakre presenting ICTCS 2025. My paper ID is 290. Title of the paper is Machine Learning for Early Prediction of Chronic Kidney Disease, Critical Challenges, Ethical Consideration, and Future Research Pathway. I am from School of Allied Science, Faculty of Science and Technology, Datta Mege Institute of Higher Education and Research, Savangi Mege, Wardha. This is the content of my presentation: introduction, literature review, data model, ethical and clinical challenges in ML-driven CKD prediction, research gap, need of study, objective of research, conclusion, and references. This is the introduction of the topic. Chronic kidney disease (CKD) has emerged as a silent global epidemic. According to WHO, worldwide around 850 million people are estimated to have a kidney disease from various causes. 10% of Indian population affected by CKD. CKD not only affects the quality of life but also places an immense burden on healthcare system worldwide. CKD characterized by a gradual deterioration of kidney function over an extended period. Early diagnosis of CKD is crucial to improve the quality of life. This is the literature review. First study objective are temporal disease progression. Model is recurrent neural network. It has procedures 10 to 50 percent versus logistic regression. Practical insights is temporal models improve logistical CKD prediction. Second objective is handle class imbalance. Model is smooth and it has F1 score 0.89, and practical insight is balance prediction for minority CKD cases. And third objective is interruptible deep learning. Model is deep learning sharp, and it has accuracy 94, and practical insight is enhance clinician trust via transparency. Fourth objective is CKD risk in type of 2 data diabetes, and the model is ML random forest, and it has accuracy is 84 to 92%, and practical insight is effective early detection in high risk group. And fifth objective is multiple center privacy preserving, and the model is federate learning, and it has accuracy 0.87, better than centralized, and a practical insight is preserve privacy while enabling collaborative training. This is the data model, ethical and clinical challenges in ML-driven CKD prediction. Data challenges are scarcity of early stage CKD data, class imbalance, fragment record missing values. Model challenges are overfitting a small data set, limited generalizability, black box models, and ethical concerns are privacy and data security, algorithm bias, and accountability issues. And the clinical barriers are lack of clinician trust, high cost of implementation, integration with the HRS. Features pathways are federate and multi-center data sharing, interpretable and fair ML models, temporal and the multi-models analysis, policy and interdisciplinary collaboration. This is the research gap. Despite the promising advancement, research on kidney disease prediction using machine learning ML still faces several critical gaps. Variability in accuracy across study and algorithms, undetailing of ensemble and hybrid models for the accuracy improvement, limited attention for the feature selection and data quality for accuracy optimization. This is the need of study, delight the diagnosis in traditional methods, importance of early detection, superior performance of ensemble learning, critical role of features engineering. This is the objective of research and research methodology. First aim is to understand the suitable machine learning techniques for the early kidney disease prediction. Research objectives are to study different machine learning techniques and existing early predictive model for the kidney disease. And the research methodology used are literature review of existing research on machine learning and early kidney disease prediction, analysis of existing early kidney disease prediction models. Second aim is to assess the effectiveness of the existing models. Research objectives are to analyze model performance of different existing early predictive model for kidney disease. Research methodology used are collection and analysis of dataset for early kidney disease prediction, evaluation of existing model using metrics like accuracy, precision, recall, F1 score, and AUC ROC curve. And third aim is to develop a novel model for early kidney disease prediction, improve accuracy. And the research objectives are to develop a novel, accurate predictive model for kidney disease. And the research methodology used are selection of suitable machine learning techniques based on objective 1 and 2, features engineering and data pre-processing, development and training of the novel model. And fourth is to compare the performance of the novel model. Research objectives are to evaluate model performance, and the research methodology used are evaluation of the novel model using metrics like accuracy, precision, recall, F1 score, and AUC ROC curve. This is the conclusion. Machine learning holds significant promises for the transforming nephrology by enabling early and accurate prediction of kidney disease. With continued advancement in data collection, model development, and validation methodologies, these technologies have the potential to become integral tools in clinical decision making, ultimately leading to better healthcare outcome for patient and risk of kidney disease. These are the references. Thank you.
Thank you, ma'am, for your presentation. Now we will go on to the next presenter.
Mhm.
So the next presenter is Nikita Girimat from KLE Technological University, and the paper title is Reinforcement Learning Based Adaptive Beam Selection for 5G Wave Networks. Ma'am, please start with your presentation.
So is my screen visible?
Yes, ma'am.
Good afternoon to one and all. I'm Nikita Girimat from KLE Technological University. I'll be presenting a paper titled Reinforcement Learning Based Beam Selection for 5G Wave Networks. 5G networks aim to provide high speed, low latency, and support for many users. However, they are highly directional and sensitive to obstacles. To maintain reliable communication, beam forming and beam selection are required. So, In 5G network, communication happens using very high frequency signals. So to provide high data rates, but they suffer from blockages and all. So choosing the correct beam direction and at right time is very important. So hence the problem is to design an intelligent system that can adaptively select the best beam in real life. So this is what we have designed, which is to we what we have done to design and implement a reinforcement learning based beam selection for 5G waves. uh, our project focuses on mainly four objectives, which is maximizing SINR, minimalizing latency, improving handover success rates, and scalability. Through the literature survey, what we have done, uh, we observe that machine learning and reinforcement learning techniques outperform traditional beam selection methods. Many works use deep learning, but they are computationally complex. So our approach uses Q learning, which is lightweight, model free, and suitable for real time implementation. Uh, the block diagram shows how the RL agent interacts with the network environment. Uh, First, the environment setup includes base station, user equipments, beam and SINR. Then the state analyzer collects the SINR, user equipment speed, position for information purposes. Then in RL agent, we have used Q learning, which takes the state as input and selects the optical beam. For beam selection and logging, it will select a beam which is applied, and performance metrics are stored in direct CSV files. Then the performance evaluation is done. So in this Q learning algorithm which we have used, it is a model free reinforcement learning algorithm. It learns the best action for each state by maximizing cumulative reward. In our system, state represents network conditions and actions represent beam directions. Over time, the agent updates its Q table and converges to an optical beam selection. So basically how it works is, first we create a 5G mmwave simulation environment in MATLAB, then a base station with multiple directional beams is considered, and a mobile user moves across the coverage area. Next, the parameters such as SINR, user position, uh, and speed are collected. These parameters form the state of the environment. Then the Q-learning based RL agent observes the state and selects the best beam as an action. So based on the resulting SINR and connectivity, the agent learns the agent receives a reward. Over multiple episodes, the agent learns the optical beam selection strategy. This is the This graph show that the RL agent successfully learns better beam selection over time, where the blue line is episode reward, which is obtained in each episode. Where early episodes fluctuate because the agent explores randomly. Then the thick blue line is average reward, which is smooth curve showing learning progress, indicates stability and convergence. And the yellow line is Q value. It shows confidence of the agent in its decision. And it also increases as learning improves. After training, the system achieved an average SINR of 24.6 dB, where our target was more than 20 dB, where the actual average SINR is acceptable range is greater than 20 dB. Then latency is 5.31 and handover success rate is 93.5. These results outperform static beam selection methods, and all these metrics were logged in CSV files for analysis. In conclusion, our work demonstrates the Q learning based reinforcement learning, which can effectively improve beam selection and handover performance in 5G MM-based networks. So the proposed approach is adaptive, scalable, and quite efficient. So in future work, we are planning to extend this using deep reinforcement learning and real-time hardware implementation. Thank you so much. This was all about my project.
Thank you, ma'am, for your presentation. Now let's move on to the last presenter. So the next presentation is by Badikala Chaitra Srinivas from RMK Engineering College, and the paper title is Safe Pro: Smart Assistive Framework for Falls in the Elderly. Proactive Risk Observation. Ma'am, please start with your presentation.
Yes, hello. Can you guys hear me?
Yes.
Yeah, I'll start. I hope my screen is visible.
Yes, ma'am.
Yeah. So, good afternoon, everyone. My name is Chaitra, and I am an undergraduate student from the Department of Electronics and Communication Engineering at RMK Engineering College. Today, I will be presenting my work titled Safe Pro: Smart Assistive Framework for Falls in the Elderly, Proactive Risk Observation. This work focuses on predicting fall risk early instead of reacting after a fall has occurred. The motivation behind it, falls are one of the major causes of injury and hospitalization among elderly individuals. And from a technical perspective, falls require timely intervention to reduce severity and long term impact. Most existing systems which focus on fall detection monitor basically after the fall has occurred. While these systems are useful for emergency response, they do not support fall prevention. And reactive alerts are generated only after the impact, which limits the possibility of preventive measures. In addition, continuous elderly monitoring is required uh, so that the systems are reliable, fast, and suitable for daily uses. And this motivates the needs for the system so that the fall can be predicted before it actually occurs. Here's a research gap. Well, there are several systems which exist, but most of these are mainly focused on reactive. As I've mentioned, they're reactive in nature. And the other main point is most of these rely only on single sensor data. And this reduces the robustness in complex movement scenarios. And another thing is that most of the existing systems are cloud dependent, and processing is also done on cloud. So this introduces a lot of latency, connectivity issues, and privacy concerns. And another major thing which is not much focused is the usage of multiple sensors into the system. And this combined with lightweight on-device processing for early fall risk prediction is not much focused on. And this is what forms a gap, and this is what my work focuses on. So here's the proposed framework. So SafePro is proposed as a wearable edge intelligent framework for fall risk prediction, not detection. It is prediction. The system continuously monitors both movement related data and basic physiological signals. When it comes to movement related data, you have motion sensors, gyroscopic sensors, and etc. to detect such data. And when it comes to physiological signals, for now, I have opted for a heart rate sensor to detect for physiological signals and irregularities in heart rate. And instead of sending the data to the cloud, all analysis is performed directly on device. That is, as I've mentioned, it is edge intelligent. And this allows the system to operate in real time with low latency and without any internet dependency from the edge device point of view. The framework is modular in nature as the system is divided into further layers, which I will be further explaining in the next slide. And this supports future extensions such as personalizations and improved prediction models. And this is the overall framework. I'll go to the next slide for the system overview. So this is the system overview in short. So basically, in the system overview, we have four main phases in it, and then we have common phase, which is eligible for all the other phases. So starting with, we have our sensor interface, and this is the sensor interface layer. This is the phase where the raw data is collected from the sensors. And as I've explained, the motion sensors, these capture the gait, balance, and rotational motion of the user. And when it comes to the heart rate sensors, it calculates the irregularities in the heart rate, and this is from the physiological context. And to the next layer, this is signal processing and feature extraction layer. This is where all the data collected in the first layer is cleaned and the noise is removed. And features are extracted from the data which are relevant for the next layer to study on. And in the third layer, this is our Edge ML inference engine. This is basically where our lightweight model works. And from the features which were extracted from the data on the previous layer, this is studied and it is used to identify any fall risk scenarios or high risk situations. And based on this information is sent to the next layer, which is our feedback and alert mechanism. And in the feedback and alert mechanism, if such a situation does occur, that is a high risk situation is predicted or fall is predicted, the alert is sent immediately to the user and the user is indicated about it, either based on either using let's say vibration sensors or a buzzer or even voice, if it is for the future scope point of view. With the help of this, the user can be alerted saying that they're not quite stable, a fall might occur, to take precautions based on it. And coming to the power management layer, this is the one layer which is important throughout for all the other phases. And optimized, and it is optimized for long-term wearable use. And it uses low power modes and make sure that all the sensors whichever are used are low power sensors so that the system could last longer. That is, the usage of the power would be less. And also measures such as duty cycling and other such techniques can be used to ensure longer lasting power management. And coming to the future scope, this work currently focused on the framework and feasibility point of view. It is a proposed system, and the implementation and real-time validation are planned as part of the future work. It needs to be done as the next step. And future extensions could include training more robust machine learning models and personalizing prediction based on individual gait patterns and conducting real testing with elderly users and integrating with caregivers or mobile applications or clinical validation are also planned to evaluate practical effectiveness. And from the sensors point of view, more sensors, especially related to the physiological sensors such as oxygen SpO2 sensors, the SpO2 sensors and the temperature sensors, these can be included to give better context to the users or the caregivers. And cloud support can be added for long-term analysis. while keeping real-time decisions on the device. So based on this, the patterns can be analyzed by the doctors or the caregivers to ensure the feasibility of the device. Coming to the conclusion, SafePro is a proactive framework and for fall risk assessment using wearable sensing and edge-based processing. And by shifting from reactive detection to early risk identification, the framework aims to support timely intervention. And overall, this work seeks to improve elderly safety, independence, and quality of life through intelligent real-time monitoring. Thank you so much.
Thank you, ma'am, for your presentation. Now, with this one, we conclude the session, and all of the presentations are done. There is only one absent member, which is Upasana Singh. So, if any of the co-authors from her paper are present here, they can present right now, or will proceed for the closing remarks. Okay, so I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 8 versions of the conference. We will be happy to have you in the 11th version in 2026. Now, all the presenters would be getting their digital certificates via email within 2 working days, and the publications will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS. I also thank our session chair, Professor Vishal Patil, for chairing this session. A token of appreciation for the chair on behalf of Team ICTCS. Thank you so much, sir, for
Thank
your
you.
valuable presence. Now, before ending this session, I would like to request all of you to please turn on your camera so that I can take a quick snapshot of this conference. We'll just wait for a few seconds for everyone. Okay, I've taken the snapshot. Thank you, everyone. Thank you for this wonderful session. Now you all can leave the meeting.